Okay, let's move on to part B. A radio company claims that a new transmitter set up in Radville will reduce the proportion of houses which are unable to receive digital signal. After the new transmitter has been set up, a random sample of 15 houses, so N is 15, is taken, of which one house is unable to receive digital. So our observation is 1. Okay. And we were told earlier that it was a 25% chance. So, to get our marks, first of all, we have to state that x can be modelled binomially with n is 15, and we're investigating whether or not the probability is 0.25. We must state our null hypothesis. That's the status quo. That is, what's the chance if nothing has changed? And that is the probability of 0.25. Our alternative hypothesis, okay, the new company is aiming to reduce the proportion, so fewer, there's a lower probability of not being able to receive digital. This is a one-tailed test. We are only looking at the chance that it's less than 0.25, not at the other end. We're asked to test at the 10% significance level. Okay, so we've got our first mark by stating the modelling. We've got our second mark by stating our hypotheses. We now have to find out the probability that x is less than or equal to 1 because we observed 1. What's the probability of that happening? So if we go to n is 15 and a probability of 0.25 and an observation of 1, we find the probability is 0.0802. Okay, so if the probability of it happening is 25%, there's an 8% chance of making an observation of 1. We are told that our cutoff is 10%. Okay, which tells us that 8% is too extreme because our cutoff is 10%. So 8% is too extreme. It's extremely unlikely that that you get an observation of 1 when the probability is 0.25. So we get a mark for calculating our probability. Okay, if you want to say it, that's less than 10%. So we have a significant result. We've got evidence to reject the null hypothesis, but you must put that in context. So there is evidence that the company's claim is true.